looks like it, okay. All right, so here we go, let's do it. All right, what this whole sheet is about is seeing the difference between a number attached like that one and a number attached like this one. Okay, so here we go. Here are the first three. Do you notice that these two, the number is attached in the same way?
Yeah.
This one, the number is attached in a different way. All right, so what does that mean in terms of the picture?
One of them is left and right.
These guys go left and right. This one's going to go up or down. So this shape is what? What shape is this? That's your V. And it is going to go up one. So we're going to draw our V up one, and we're going to label that point to indicate that it went up one. Now, which way? These are going left and right. Which way is this one going? To the right. This one is going to the right. So it's going to be a parabola opening to the right, or opening up, but 2 units to the right. I think it was Navi in the other class said, I think about it like this. If I set that equal to 0, x is 2. That's how he thinks about it. That's up to you. That's how he thinks about it. So this one is going to be moved 1 unit to the left. Now this equation or picture is a little more complicated. This one has an asymptote at 0 and an intercept at 1. It looks like that. That's what your logarithmic curve looks like. The entire picture, everything has been moved 1 unit to the left. Okay? Which means that the asymptote is now at -1, and the intercept is now at 0. When you move the picture, you move it all. Asymptotes, everything moves when you shift your picture. Okay. Now, what about this one? It's going down 2. It's going down 2. Well, again, this is a little more complicated. Your exponential has an asymptote at 0 and an intercept at 1 and looks like this. That's your exponential. So you're taking the whole shebang down 2. So that asymptote is now going to be down here at -2. And that dot is going to be now down here at -1. So it's exactly the same shape. We haven't changed that. We've just dropped it down 2. All right. Now the next one. What's happening to the next one? Avery, I don't see you, and if I can't see you, it doesn't count as being present, so please turn your camera on. All right, so y equals x squared plus 3. How's this one moving? No, no, no. If it were moving to the left, it would look like this. We have got to see the difference in those 2 equations. If you can circle your BFF, then it's going to go up and down. Do you see I can't circle my BFF because the number is in the middle of the problem? When the number is in the middle of the problem, it's going left and right. There's nothing to understand there. We memorize that. This goes left, this goes up. So what shape is that? It's my parabola, and it's going up 3. Now, what's happening to this one? This is my BFF. Can I circle that here? Is that circleable here? No, because that's there. So which way is this going? Left. What's number 7 doing? Which way is number 7 going? It's going right. What shape is it? Well, it's my squiggly, right? So it's going to come up and squiggle through 2 instead of through the origin. Normally that squiggles through the origin. This one is squiggling through 2. What's 8? What's happening with 8? Going down 4. Now I heard somebody say going to the right with the linear function, it really doesn't matter because there's no parentheses or anything. So either way, you're going to get the right answer. Here's your original. If you bring it down 4, or if you take it right 4, aren't you going to get exactly the same line? So I think of it as going down 4. That's how I think of it. But for the linear function, you can also think of it as going right 4. All right, what about number 9? What's happening with it? Going left 3. And what shape is it?
Shoot, like it shoots out.
Like that?
Yep.
So notice that on all of these problems, the shapes are the same. I mean, we're not changing the shapes. We're just changing where they are. Finally, what about number 10? What's happening to it? All right, so this one went right to. This one is the exact same shape, but it is going up to. So it is going to squiggle through that point. Like it normally squiggles through the origin. I'm just going to squiggle up there instead. All right, so that's just a little extra practice. That sheet's in Schoology, so feel free to do it again if you need to practice it again now that you have all the right answers. All right, now let's get on our practice test. To save paper, there's 3 of them here, but to save paper, I didn't spread them all. I didn't spread the first 2 all out. The third one is spread out like the actual test will be, but they have exactly the same problems on them, so this is good practice. This is our practice for our test. So we'll be having a test at the beginning of next week. Please get out a sheet of notebook paper. Yep.
I don't have a practice.
Well, first of all, when you're absent, everything's in school. In the middle bin back there, the bin in the middle, there should be some. There might not be. why I have a column on my desk. You guys need to understand that when you're absent, life goes on. The world doesn't revolve around you. You gotta take care of business. Ideally, you won't be absent. That would be very best. Okay, please do this on another sheet of paper. You're not gonna be able to do everything we need to do scrunched up here. So get out another sheet of paper and let's do part one, which is our domain questions. All right, somebody put in a nutshell for me. What are the two rules for domain? What should you be thinking about when the question says domain?
What it's in a radical as
In a radical or in the denominator, right? That's what we're paying attention to. Things that are in a radical or things that are in a denominator. Look at problem number 1. Uh-oh, it's in a radical, isn't it? And what do I know about things in a radical? Whatever is under the radical has to be greater than or equal to 0. Which means when I solve that, x has to be greater than or equal to 3. Right? That's the radical rule. All right, let's look at problem B. Uh-oh. Does problem B have a radical? Yes. So let's deal with that. X plus 1 has to be bigger than or equal to 0. So x is greater than or equal to -1. But what else does problem B have? A denominator. And what do we know about our denominator? Can equal 0. So x minus 2 cannot equal 0, which means x cannot equal 2. And both of these are answers to problem B. You have to have them both. Why are there 2 answers? Because there's a radical and a denominator.
So the denominator will always be does not equal?
Yep.
Okay.
Those are the rules that we wrote down in our notes the first day we talked about this. Whatever's under the radical has to be greater than or equal to 0. Whatever is in the denominator cannot be 0. All right, what about C? All reals. Because what does C not have? No denominator and no radical. And if you have no denominator and no radical, then you have no problem. It's fine. All right, what does D have? It has a denominator. So whatever is in the denominator cannot be 0, which means x cannot be -6. So when we do domain, what are the 2 things we look for? Denominator and radical. Right? That's all. That's all we have to look for. Okay. Well, we just talked about this one. How do we find the implicit functions for the graph? What do we have to do here? Y equals, okay? So somehow you're going to rearrange your equation to get y by itself. So you should have either, well, no, this is what you should have. You should have y squared equals x squared minus 9. You could also have -9 plus x squared if that's what you have. Then what do I need to do though? This is not the answer. How do I get an answer out of that? Now that I've gotten y by itself, now I gotta square root it. And when I square root it, what do I need to remember? Plus or minus. So y equals the positive square root of x squared minus 9, or y equals the negative square root of x squared minus 9. Those are the answers to the question. When you get your test, there will be 2 answer blanks to remind you that there are 2 equations. Are we ever going to simplify what's under here? No. It doesn't simplify. So don't. That's the answer right there. All right. Now this is a big section here. We have to find horizontal, vertical, and holes. All right, so part 3, here we go. Horizontal, vertical, and holes for this equation. I'm going to say there's no holes. How do I know that? How do I know there's no holes? How do I get holes?
Oh, because it doesn't simplify like that.
You can't cancel. And factoring and canceling out parentheses, that's how you get holes. If you can't factor anything, and I can't, right? Nothing's going to factor there, then there aren't going to be any holes. Holes only happen when you do some factoring and can do that. That's how you get holes. Otherwise, you don't have them. How about asymptotes, though? Do you remember? How do we get the horizontal and vertical asymptotes from this picture?
We use the denominator.
Vertical, you look at the denominator. And what do I know about x? It can't be, well, x can be 0. X plus 1 can't be 0, which means x can't be negative 1. So your vertical asymptote is at negative 1. What happens if you put negative 1 in that problem? You get a 0 in the bottom, right? Is that allowed? No. So you're going to put a vertical asymptote there. Where's my horizontal?
The 2 x's.
Yep, I look right here. Very good, Olivia. I look right there. So where's my horizontal asymptote? Y equals 3. And we're not going to mix those up. Look at my problem, guys. Y equals 3 over 1, right? Y equals 3 over 1. That's my horizontal asymptote. All right, what about the next problem? Is this one going to have any holes? Problem B. Well, now be careful. You can factor, but is anything going to cancel? How do we get holes? Only if we cancel. And nothing cancels. Right? So no holes. All right, what about asymptotes? Horizontal and vertical asymptotes. What about those? Where's my vertical asymptote? X equals negative 5. X equals negative 5 is your horizontal asymptote. Or vertical, yeah, that's my vertical asymptote. X equals negative 5 is my vertical asymptote.
Yeah, 'cause
What about my horizontal asymptote?
it's gonna be 1.
Nope, it's not going to be 1.
2.
It's going to be none. And the reason that it's none is, how do we find our horizontal asymptote? We box in our x's, right? But the rule says we got to box in the highest power only. So what's the highest power of x I have in the problem? Squared. The highest power altogether in the problem is x squared, right? There's one of them on the top. How many x squareds are in the bottom? 0. So when I box them in, it says y equals 1 over 0. Is 1 over 0 okay? No, that's why there's none, because you can't have 1 over 0. We talked about this before. I'll say it again. When the power on top is the biggest, you'll never have a horizontal asymptote. Okay? When the power on the bottom is the biggest, your horizontal asymptote will be 0. Every time. Never changes. That's how it is. So if you can't remember that or make sense of that, then that's one more thing you can just memorize. When the power on top is bigger, there's no horizontal asymptote. When the power on the bottom is bigger, the horizontal asymptote will be at 0. Every time. When they match, it's like Olivia's problem over here. That's the best case. When they match, it's just that ratio. 3 over 1. Okay, one more. What are we going to do with this? This is a big one. Yeah, we probably ought to try to factor everything. What can I do to the top?
Take out a 3.
Take out a 3. And then I can factor the difference of squares. Right? What about the bottom? What can I do to the bottom? Is it factor?
Yeah.
X
Minus 3.
minus 3 minus 1. Uh-oh, what happens? We can cancel, which means our new problem is this. That's all that's left after we cancel. What does canceling mean I'm going to have? A whole. Remember one. There's only one thing canceled out. And that's going to be where x is 3. The factor that canceled out gives you where the whole is. So x minus 3 canceled out, so x is 3. But the whole is a point, so it needs 2 parts. How am I going to get the second part? Plug it in. Plug in 3. And where will I plug 3 into? My problem, right? My new problem right here. So I'm plugging it in right here. So 3 times 3 plus 3 over 3 minus 1. I'm plugging in 3 into my equation. So that'll be 3 times 6 over 2. Is that 9? So my whole is at 3, 9. One more time. Where do holes come from? How do you get them? If you can factor and cancel. Once you have canceled, whatever canceled out gives you the x, and then plugging that back in gives you y. Your whole is a point. Now, let's look at this right here. Does it have any asymptotes? Does it have a vertical asymptote? X equals 1. Now, in the factored form, get a little creative here. When I box them in, don't I have 3x over x? If you boxed in the original problem, you have 3x squared over x squared. Either way, where's your horizontal asymptote? Y equals over 1x. All right, that's a big problem. Anybody have a question about that? It's a big one. Summarize, where do holes come from? Factoring and canceling. Where do vertical asymptotes come from? Denominator. Where do horizontal asymptotes come from? Box them in the x's. Yep. The highest power of x. Okay, now we're going to do some sketching. This whole test only has 5 sections to it.
Only faster.
So there's not that much on it. Alright, so the first thing we have to graph is a piecewise function. So feel free to use colored pencils. If you want, definitely have an eraser. Alright, who remembers how we start this?
Don't you put an asymptote at 2?
Yep, I put some kind of a line at 2. So it isn't really an asymptote, but you can graph it as an asymptote,
Okay.
or a squiggly line, or something. You need to indicate something's gonna happen at 2, right here. Okay? Then we just kind of ignore that and look at this right here. What is y equals 2x plus 1? What shape is that? It's a line with a y-intercept at 1 and a slope of 2. So I'll just count up 2 over 1, up 2 over 1, and so on. Oops. I'm gonna try to make a straight line there. I missed some of my points, but there's my straight line. And then what do I look for? Where it intersects my whatever, squiggly line, asymptote thing, whatever, where it intersects. Okay, right there is where it intersects. Will that dot be open or closed? Open, so I'm gonna make sure it's nice and open. And then remember, we're going to erase part of our picture. This tells us what to keep. So I'm gonna keep the right side, which means I'm going to erase all this work I just did. So it's good to have a pencil with an eraser. All right, what's that? That's my asymptote value, but it's a V, right? So I'm going to go ahead and draw my V in, right there at the origin, just V'ing up. It crosses right here. Open or closed? Closed, because of this. And then this tells me what to keep, so I'm going to keep the left side, which means I will erase that little piece. Now, if you want to take out your squiggly line and your asymptote, whatever it is, if you want to take that out, you can, you don't have to, but there it is. It's called a piecewise function because it's literally in pieces. Now the rest of the sheet is, the rest of this part, I mean, is easy because we just practiced it. What does B look like? It's a V and it's right free. So label your point and draw your V. That's all there is to it. C's a hard one. What's gonna happen with C? It's your sine curve, but what's it doing?
Moving down.
Moving down one. Now, here's what's tricky about this one. I'm gonna go ahead and graph my regular sine. But remember that your regular sine bounces back and forth between -1 and 1. That is important for you to remember. So what happens when I take that picture and drop it down 1? Now it's gonna bounce between 0 and -2. So now it looks like this. Oops. That's a hard one. That's a tricky one. It bounces between 0 and -2 because you dropped everything down 1. Well, luckily D is a lot easier than that. What shape is letter D? A parabola. How do we know it's a parabola? Because it's a square. Now, it has actually made 2 moves. Letter D has made 2 moves. How has it moved?
Down to left.
This went down 2, and this went left 1. So isn't our parabola sitting down here, left 1, down 2? Because you put a number inside and a number outside. The inside one goes left and right, the outside one goes up and down. So it's your regular parabola, but now it's sitting down here. What's that one doing? That one is going up 1. So it is your cubing curve, which is your squiggly, but it's up 1. I hope you're watching how I'm graphing that. Did you see how I graphed that? That's how you do it. Oh no, this one has 2 also. How is this one moving? It has an inside number and an outside number. So inside goes this way, outside goes this way. So how's this going? Right 3 and up 2. Right 3 and up 2. So right 3 and up 2, and then it's the square root shape. Is that all right with everybody? Okay. One more section, and that's it for the whole test. One more section here. So we've got these 2 functions. And we're going to do f of 2 plus g of -3. You know how to do this. This is easy. What are we going to do? What's What's f of 2?
F of 2 is 9.
9. How do you get 9? You put 2 in right here. What's 2 squared? 4 times 2 is 8 plus 1. Everybody got 9? What's g of negative 3? Negative 13, because it's negative 9 minus 4, negative 13. So the problem says figure out f of 2, figure out g of negative 3, and then add them. So the answer would be negative 4. Everybody got it? That's easy, right? Easy. Right in. All right. B is equally easy. Actually, it might even be easier because you just have to take f of x, which is written right here, and subtract g of x. So it's this one minus this one. Now, the one place where you might make a mistake is if you forget these parentheses. Because since we are subtracting the whole quantity, we need to distribute. And then if there are like terms, you should combine them, and then you're done. That's it. You don't do anything to that. That's it. Once you get your like terms put together, you're done.
When's this test due?
The very first class we have next week, so I don't know what day that is,
Okay.
but I think that's right. We have 2 classes left this week, and then next week. Okay? C, f of g of 3. All right, we did this yesterday or the day before. How do we start this? 3 goes into g. So 3 goes into g, and what would I get if I put 3 into g? I get 5, okay, good? And then I take, this is 5, I take the 5 and put it into f. So watch the math here, guys. What do I do first? When I put a 5 in there, what do I do first? Exponent, exponent, PEMDAS, PEMDAS. So this becomes 25 times 2 plus 1. 51. And the last one we're going to do today. Let's make it good. Oops, I need to keep those. Last one says find g of f of x. So this says, I don't know if you heard what Ethan said, but he hit it right on the head. He said, plug f, whatever f is, which is, this is what it is, plug f into g. So take the f function and put it in place of x, substitute it in to g. So we'll have 3 times 2x squared plus 1 minus 4. This goes right here. And then we do our cleanup. So 6x squared plus 3 minus minus 4. I got 6x squared minus 1. Is that what you got? All right, good job. We just did the whole first practice test. So you can see